Hello students, today we'll be working on doing the integral with exponential functions. So just like with the derivative, the antiderivative of e to the x is itself e to the x. And if you have e to something other than just an x, then you'll need to use a u as we have done before. So you'll find that with integration, some of the struggles that we've had before, we may continue to have in determining what would be a good u and then how to rewrite our integral. So just as some general reminders, if you have a quotient, often it is the denominator that is the u, not including any outside exponents. If you have a product or you have a trig function, then your argument of the trig function would be the u that you would want to use. So we'll start with your first example, and since it's a quotient, we'll use the denominator for the u, and that will be e to the x plus e to the negative x. And then we'll do the derivative of that, so du, which would equal e to the x, so itself. And then the derivative of e to the negative x would be itself, so e to the negative x, and then it would be times the derivative of the negative x, so it would be times -1. And I'm just going to go ahead and put that as a minus sign, and then we'll have dx. So we look to see if we have, and we have to have this exact match, this e to the x minus e to the negative x. So we're close. We have that with the 2. So if I factor out the 2 and then rewrite my integral, I would have 2 and then the integral of, and I'm going to go ahead and put the denominator to a negative power. So e to the x plus e to the negative x to a -2 power. And then I'll have my numerator with the 2 factored out. So my numerator, which is e to the x minus e to the negative x, and then the dx. So this gives me the u that I needed. This would be the u, and here is the du. So I can integrate u to the -2 du. And then that's just the power rule. So doing the integration, I would have 2 and then u to the -1 over -1. Remember to add on c, and then you can simplify and resubstitute, making your final answer -2. And then since this is u to the -1, when I resubstitute, I'm going to put this in the denominator, going back to what my definition for u was, which is e to the x plus e to the negative x, and then plus c. So there's an example of integration when the e to the x function is involved. You'll see it again here with the trig function. So let's go ahead and take a look at problem 2. So I do have a product, but I also have this trig function where my angle is not just an x. So that is generally a good choice for the u. So the u would be e to the negative x. And then as we do its derivative, du, we would have itself, e to the negative x, times the derivative of the negative x. And so we would have -1. I'm just going to put a negative in front of the e, and then remember that we have dx. So negative e to the negative x dx. All right, so as I look, that is exactly what I have except for the negative sign. So I can put a -1 on the outside, and then I'll rewrite having the tangent of my e to the negative x first, and then putting in the -1 that I need, so multiplying by -1, and then having my e to the negative x. That would make, then when I put the du with it, that would make when I put the dx with it, that would make my du. So what I'm really integrating then is -1 with the integral of the tangent of u and then du. So the antiderivative of tangent of u, this is one of those that I let you have a cheat sheet for, so you may not know it as well, but it's -1, and then this antiderivative is negative. It's the negative of the natural log of the absolute value of the cosine of the u, and then plus c. And then I should have done that in a different color. This is your antiderivative. I'm not going to change it now. And this double negative would make a positive, so that your final answer, natural log of the absolute value of the cosine of, and we can substitute in our u, which was e to the negative x. So always remember to go back to that, and then plus c. So final answer, natural log of the absolute value of the cosine of e to the negative x plus c. So those are the examples that I am showing you for doing indefinite integrals. We're going to take a look at 3 different types of what I would say are maybe a little bit more on the application side. The first would be the use of the fundamental theorem of calculus. So as we do this, we will again see that we'll have to use a u. This looks like a really complicated expression with a product. Now, in the case of e, if you have an exponent that is not just an x, that is usually a good choice for the u. So I'm going to let that be the u to start. So our u is, now this is x to the third over 2. I'm going to write that as 1/2 x to the third power. Doing the derivative du, I'll bring my 3 in front, making 3/2 x to the second power, and then dx. So in looking at what we have the integral, and since I'm keeping my x's for the time being, I'm going to go ahead and keep it from -2 to 0 of e to the 1/2 x to the third power. And then I have my x squared dx. So I need 3/2 multiplied by my x squared dx. So I have to balance that with 2/3 on the outside. And so in my rewrite, I will have 2/3 times the integral. Now I'm going to switch to e to the u, and here du. And when I switch to the u, I need to adjust my limits of integration. So for the top one, u of 0 means that I'm going to plug in 0 for the x. So 1/2 times 0 to the 3rd, which is going to give me 0. So the top is going to stay 0. And then u of -2. So I'll have 1/2 -2 to the 3rd. And that's going to be -8 times 1/2, giving me -4. So -4 is my new lower limit of integration. So now this is the first one I've shown you that actually integrates e. So we will integrate with e, and that'll be 2/3, and e to the u is its own integral. So I get e to the u, and then this is evaluated on -4 to 0. So I'll be plugging those values in, and you can put the 2/3 in or outside of the e to the u. So if I continue on up here, I'll have 2/3, and then evaluate e. Remember, you put the top in first, e to the 0 minus e to the -4 power, and do a little bit of cleaning that up. E to the 0 is 1, and e to the -4 is 1 over e to the 4th power. And so to finish cleaning that up, we like to have this all as one fraction. So as a general rule, please give me your final answers as one fraction. So we'll have 2/3, and I'll get a common denominator, making it e to the 4th over e to the 4th minus 1 over e to the 4th. And then I can make that 2/3 times e to the 4th minus 1 over e to the 4th. And then if you want to put the 2 on the top and the 3 on the bottom, 2 times e to the 4th minus 1 over 3 e to the 4th. And that would be how we'd like to have your final answer end up on an answer with e in it. Okay, so that's a definite integral. We'll continue on to the back where we will solve a differential equation. So if you'll turn your papers over, we'll move to the back. And we will be separating the dy and the dx. So remember that we do dy equals, and then e to the x minus e to the -x, all of that squared, and then have the dx with it. And we will be integrating both sides. So the antiderivative of dy is just y equals. Now this side, I have a product, and I'm going to need to multiply this out in order to do the antiderivative. So I'm going to do that work off to the side, taking e to the x minus e to the negative x times itself. So taking e to the x times e to the x, adding the exponents, we would have e to the 2x. Taking e to the x times e to the negative x, and by the way, it is negative, so we'll have negative. Adding these exponents, we get e to the 0 power. Then we'll do these two, and the same thing happens. We get negative e to the 0 power. And then finally doing negative e to the negative x times itself, we'll have a positive e, and then the exponents will add to give us negative 2x. So these e to the zeros are 1s, and so we'll have e to the 2x minus 1 plus e to the negative 2x. And so our final answer for this part is e to the 2x minus 2 plus e to the negative 2x. And that is what we're going to integrate. So we will be integrating our answer that we got over there. So e to the 2x, and I'm actually going to go ahead and separate this. So e to the 2x dx, and then minus the integral of 2, whoops, let me change colors, the integral of 2 dx, and then plus the integral of e to the negative 2x dx. And I think you'll do better to have that separated in that form. So we'll have y equals, and now we're going to begin doing the integration. So y equals, all right, for this part, you'll need to use a u. So I'm just going to write that right in here. Your u would be your exponent of 2x. Your du would be 2 dx. And so you need a 2 and could balance this out with 1/2. So what you're really going to be integrating is 1/2 times the integral of e to the u du. All right, now on your next one, if you want to go ahead and do the integral, you could. Just make sure you're keeping track of your symbols. So we could integrate 2 dx and have minus 2x for that part. And then we'll have to use another u up here. So u could equal negative 2x. Your du would be negative 2 dx. So we need a negative 2. We'll balance that with a negative 1/2. And so we'll have negative 1/2 times the integral of e to the u du. So now we can finish the integration process. We'll have 1/2, and the antiderivative of e to the u is itself e to the u. And then we have minus 2x, and then we have minus 1/2, and the same thing happens here, e to the u, and then plus c. And finally, we'll have to go back and put in the value of the u. So our final answer, y equals 1/2 e. Now this first u was 2x, so you have to keep track of that. E to the 2x minus 2x minus 1/2 e. The u for this part was negative 2x. So see, they're different values. And then plus c. So your final answer would be this y equals, and you have this equation, 1/2 e to the 2x minus 2x minus 1/2 e to the negative 2x plus c. Your final problem is to find the solution where you're given f of 0 equals 1/4 and f prime of 0 equals 1/2. So remember that if you start with a second derivative, you integrate twice so that you can get to the original problem. So we'll start integrating both sides. The antiderivative of f double prime of x would equal the antiderivative of sine of x plus e to the 2x dx. So antiderivative of f double prime is f prime of x. The antiderivative of the sine of x is the negative cosine of x. And then you may have to slow down just a little bit and actually do the integral of e to the 2x on a separate line. So go ahead and maintain that integral sign, just you're distributing it. We already did the antiderivative of sine, but not of this, because you're going to need to use a u. Your u for this one's going to be the exponent again. So u is 2x. Du would be 2 dx. So we need a 2, and on the outside balance that with a 1/2. So now we'll have f prime of x equaling negative cosine of x. And then you'll have, if we kind of slow down here a little bit, we'll have the plus 1/2 times the integral of e to the u du, and then integrating that, negative cosine of x plus 1/2, and it's its own antiderivative, so it'll end up being e to the u, and I think you could handle going ahead and substituting in that value for u. So e to the 2x, make sure you know that's an e, and then plus c. So at this point, we will use our f prime information. So f prime of 0 equals 1/2. So we would plug in 1/2 for the y value, and then do the negative cosine of 0 plus 1/2 e to the 2 times 0. And remember that 0 is going in for the exponent, so it does not make this just completely disappear. So you have 1/2. Now, the cosine of 0 is 1, so this will be the negative of that. So you'll have negative 1 plus, and then this is 1/2 times e to the 0, which is 1. So 1/2 times 1 plus c. And if we subtract the 1/2 and add the 1 to the other side, we're going to get 1 as our value for c. So f prime of x, that first stage, will be the negative cosine of x plus 1/2 e to the 2x plus 1. We'll continue on from here to, so I'm going to pick up close to where I left off, and there may be a little overlap. We had finished with finding f prime of x, and now we are moving on to finding f of x. So we'll need to integrate on both sides. So we'll do the, we'll do the integral of f prime of x. So the antiderivative of f prime of x dx, and then the antiderivative of the other side. So negative cosine of x plus 1/2 of e to the 2x, and then plus 1 dx. So the antiderivative of f prime is going to give us f of x. And then we can do bits and pieces of this. So the antiderivative of the negative cosine of x is going to be still negative, and that'll be the sine of x. And then we're going to need to use a u again. So I'm going to just go ahead and put plus. I'm going to bring that 1/2 out of the integral. So 1/2 integral of e to the 2x dx. And then we can go ahead and integrate the 1. So I'll go ahead and take care of that. So the 1 would integrate to plus x. And at some point then you need a plus c. I'll go ahead and put that on. But we still need to do this integration. So we'll need to use a u again for the 2x. So u would equal 2x. So our du would be 2 dx. So now we need a 2 here. And that means we need another 1/2 multiplied on the outside. So let's find out where we are, where f of x would equal. We have the negative sine of x. And then 1/2 times 1/2 would be plus 1/4. I'm still going to write it as an integral because I'm going to change it to e to the u du, and then continue on with the rest of the equation, plus x plus c. So f of x will equal the negative sine of x plus, now we can integrate. So we have 1/4, and it's its own integral. So e to the u, and we can go ahead and substitute in 2x plus the x plus the c. And so now we are using the f of 0 information. So f of 0 equals 1/4. We'll put 1/4 in for f of x and 0 in for the x. So we have 1/4 times e to the 2 times 0 power, plus we have another 0 here, and then your c. And then we'll evaluate and find what we get for c. So for the sine of 0 is, that's 0. And then we have 1/4 times e to the 0. So that's 1/4 times 1. That's going to be 1/4. And then you have plus the 0 plus the c. We subtract that 1/4 to the other side, and c is 0. So we were supposed to find f of x, and so now we have f of x is equal to, we can go back to this line, the negative of the sine of x plus 1/4 e to the 2x power plus x, with your c being 0. That would be the particular solution at 0, 1/4, and a derivative of 0, 1/2. So this is integration with e. You'll notice that it's very often that we have to use a u for the exponent, or in the case of what we did in the front, sometimes your u is the e itself. So this will be for homework 57, and good luck with your homework.